So, in this lesson, I'd like to explain the use of wind nomograms to get the real wind and also the geostrophic wind. Using nomograms is one of the simplest ways to get the real wind or the geostrophic wind. If we have the geostrophic wind, we can simply calculate the real wind. It's about 75% of the geostrophic wind, which is not quite exact, but can be used. We will first discuss how to get the wind, that means the real and the geostrophic wind. Therefore, we have to work with the geostrophic wind nomogram. But therefore, we have to check first the differences in the surface weather charts. That means the isobar differences. So here we have a chart. It's a German chart and it's a British chart, and we already can see the differences here. Because actually here we have 4 to 4 hectopascal with the isobars, the distance in between, the differences, and here we have 5 to 5 hectopascal, the differences. So therefore, some of the wind nomograms, like the Rudolph wind nomogram, is based on the 5 hectopascal differences. If we do not have any 5 hectopascal difference nomogram, we can also use the 4 hectopascal different nomogram. There is a slight difference. Should be not, but it can be used. So therefore, these charts here, these charts are actually showing the pressure and surface pressure pattern using isobars, the same as here with the British one as well, and indicate areas of high and low pressures along with their central pressure value. Isobars are represented by solid lines. High pressure is usually associated with settled weather, while low pressure is normally associated with unsettled weather. Fronts are also displayed. An analysis chart which shows the observed state of weather is issued along with forecast charts up to 5 days ahead. These are updated every 12 hours around 7:30 and 19:30 UTC, with the exception of charts for days 4 and 5, which are only issued once a day at 19:30. But this is only here with this, and in the German part, that sometimes also in British weather institutes they will do this. But we have already nowadays weather chart which will be directly represented for day 4 and 5. The reason is why they are not directly presented, and for example, like day 1, 2, 3. Is that the last 2 charts are only issued once a day because that far ahead the forecast surface pressure pattern will change more significantly due to uncertainty at this long time period. And there is a limited value in updating it every 12 hours. So therefore, the differences, what we already seen between the British chart, or let's say every weather institute who is publishing it and its British chart or in English will do this here with or Singapore, Hong Kong, Japan. They do this with a difference of 4 hectopascal, and here in Germany they do this with 5 hectopascal difference. That have to be known. So the geostrophic wind diagram. First of all, we have to check what is a geostrophic wind. The geostrophic wind will be clearly influenced by the Coriolis force and the pressure gradient force. The pressure gradient force is always showing to the low pressure or to the lower pressure and will be balanced by the Coriolis force. So where they are balancing here, and in this parallel to the isobars, we have the geostrophic wind. So this wind can be measured. Like here, that is a nomogram. This is one of the nomograms what we have for the geostrophic wind to get the geostrophic wind. So what we see, we need the distance between the isobars. That means here latitude per 4 hectopascal. And then we have here the latitudes 20 until 70 degrees, where it comes from interest. So now let's have a look. We have a surface chart here. That is our position. So first of all, what we have to do is we have the position is 44 degrees. The distance between the isobars for the set position is 2 degrees. That means we are measuring from here to here. That are the distance. It's 2 degrees, and not in hectopascal, in degrees. So with this, we are now entering this diagram. So the 2 degrees, and then here it intersects. Again, it intersects here with the 40 degrees. Here's 40 degrees. So it intersects. This is the line for this. And then we got here the geostrophic wind. Here we go parallel from the isobar axis here to the geostrophic wind axis. So, and then we can get out that the wind is now actually, the result is 32 knots, geostrophic wind. 75% of it is 24 knots. So this is actually how this nomogram is working. So again, 44, get this, in result is 32 knots. It means 24 knots wind speed. So if we now compare this with the wind diagram, and not with Rudolph's wind curve, but with the wind diagram, then, for example, this is this wind diagram. And in this wind diagram, we need to get actually the pressure difference with at 1 degree, and that have to be taken. So which means if we are using our example before, then we say, okay, we have a pressure gradient here. It's actually 2 out of the chart, and then we have the latitude, and then we would see we are coming here to 22 knots. So we had 24 knots before. So which means we can use this as an diagram for the geostrophic wind to get out the real wind, but we can also use this diagram. So the Rudolph's wind diagram and this wind nomogram will be discussed in the next lesson. Thanks for watching.